All right, we've spent some time looking at arithmetic sequences in which there's a common difference, or you're adding and subtracting to get to the next term. Now we're going to start talking about geometric sequences, in which case you are going to multiply every time, and you're going to find what we call a common ratio instead of having a common difference. So our goal today is to be able to identify it and then to be able to write the nth term. So we're going to do that both explicitly and recursively, just like we did for arithmetic. You need to know how to write it both ways for both types of sequences. So first thing, define ratio. Ratio is the division of two numbers. Okay, you have this written in your packet already. Define geometric sequence. A geometric sequence is one in which the ratio between consecutive terms are the same. So again, consecutive terms are those that are right next to each other. So if I were to take this term, and instead of subtracting the one to the left, divide by it, and this one, and divide by it, and this one, and divide by it, I should get the same number every time. So you have the fact that your common ratio is going to be some term divided by its previous term. Okay, so is the sequence geometric or not? So 12 divided by 3 is 4. 48 divided by 12 is 4. 192 divided by 48 is 4. So yes, and r is equal to 4. Negative 2 divided by 1 is negative 2. 4 divided by negative 2 is negative 2. Negative 8 divided by 4 is negative 2. So yes, and r is equal to negative 2. 1 divided by 5 is 0.2. 0.2 divided by 1 is 0.2. 0.04 divided by 0.2 is 0.2. So yes, and r is equal to 0.2 or 1/5, depending on how you want to look at it. Okay. This one's important because it looks like we're not multiplying, so our numbers are getting smaller. But we are still multiplying, it's just we're multiplying by 1/5 every time. So multiplying by a fraction less than 1. Last one then, 2/7 divided by 1/5. Well, that's not something I do in my head nicely. So 2/7 divided by 1/5 would be the same thing as multiplying by a reciprocal. You get 10/7. 3/9 divided by 2/7, so multiplying by a reciprocal, is going to be 21/18, which is going to simplify into 7/6. That is not the same as 10/7, so not geometric. Alright, what makes the following sequences geometric? Well, see if they have a common ratio. So 1/10 divided by 2/5, which is the same thing as multiplying by 5/2, is going to be 5/20, which is 1/4. 1/40 divided by 1/10 is also 1/4. So it's geometric because it has a common ratio. This one, hopefully you can look and see your common ratio. 6 divided by 3, 12 divided by 6, 24 divided by 12. Our common ratio is 2, so it's geometric. Now, just like with arithmetic, so what? Well, this geometric sequence has created a set of numbers where when I put in a certain number, I get another one back. So when I put in 1, I get back 3. When I put in 2, I get back 6. When I put in 3, I get back 12. So thinking about that, so when I put in 1, I get 3. When I put in 2, I get 6. When I put in 3, I get 12. Okay? So if I were to plot these points, it's not going to be a very good graph, but that's okay. So when I put in 1, I got 3. When I put in 2, I got, what did I just say? 6? So 2, 1, 2. When I put in 0, I'm going to get 1, right? Because I'm going to divide, this is divided by 2, I'm going to get 3 halves. 1.5, all of a sudden, I get an exponential growth graph. So with arithmetic, we had repeated addition that turned into multiplication, which created a slope. Here I have repeated multiplication, which turns into an exponential, which turns into an exponential growth graph. So our variable is going to be in the exponent. When you see a sequence that is written exponentially, that's because it is geometric and it has a common ratio. So, just like arithmetic, we can write our formulas. You have two formula boxes. First one is the explicit formula. So, we're going to have a sub n is equal to a sub x times our ratio to the n minus x. Now, this one's not totally explicit because you do still have to have information about a previous term. Okay, so it's kind of hard to think about it as explicit, but it is because you're finding exactly a sub n from the get-go. That's what your formula is set equal to. Okay, so r is your common ratio. And then n is the index that corresponds with what you're finding. X is the index of the value of the term that you already know. Okay, so those things are lined up together. If you have colored pencils or highlighters, it might not be a bad idea. Recursively then, we know that we must be given a previous term. So if we're looking for the next term is just going to be our ratio times that previous term. Okay? So, given a sub 1 equals 5 and r equals 3/2, find a sub 8. Okay, well, using our formula that we have, we know that a sub n is going to be equal to a sub x, r to the n minus x. Let's start plugging in information. So we are looking for a sub 8. It's going to be equal to, we have an a sub x, that's going to be 5. We have our ratio, which is 3/2. We have our n value, which is 8. And we have our x value, which is 1. Take out your calculators. You're going to need them for the rest of this video. So a sub 8 is going to be equal to 85.43, or 10935 over 28. Now, to put that in your calculator, you want to type 5 parentheses 3 divided by 2 close parentheses to the 7th. I don't have a calculator on this computer, and I apologize for that. Alright, this, by the way, math, fraction. Okay, you should know how to convert decimals to fractions in your calculator. Alright, next one. Find a sub 9 given this information. Well, we don't know a common ratio, and we don't know a previous term, because we don't have two terms that are next to each other. So we're going to have to use our formula and work backwards to get our common ratio, then reapply that formula to find the value of what we're looking for. So I'm going to use this one as my a sub n. It doesn't really matter, okay? But a sub n is equal to a whole bunch of stuff times n minus x. This one is going to be my a sub x. So 4 is going to go up there. 1 over 25 is going to go here. And I'm looking to find my common ratio. Alright, well, to try to find r, first thing I'm going to do is multiply both sides by 25. I'm going to get 125 equals r to the negative third. Well, that means that 125 equals 1 over r to the third. R to the third, then, is equal to 1 over 125, if you do some switching around. So that means r is equal to 1/5. If you take a cubed root of both sides, r is 1/5. Well, now that I have my r value, I'm going to go back to this formula that I already established in this structure, and say that a sub n is going to be equal to 1/25, my r value, to the n minus 4. So I want to find specifically a sub 9. So a sub 9 equals 1/25, 1/5, 9 minus 4. So a sub 9 is going to come out to be 0.0000128. Use your calculator and make sure that you agree with me on that. You could also, if you wanted to, instead of using the 1/25, you could have said that a sub n is equal to 5, 1/5 to the 9, sorry, we're looking for the 9th, right? 9 minus 1, okay? Because this would have been using that other pair of data, where n is 1 and a sub n is 5. That's fine too, you're going to get the same answer, okay? I just usually go back to the one that I've already set up for my structure right here. Alright, given a sub 5 equals 13, a sub 12 equals 13/128, find a sub 9. So this one again, I'm going to start you out and say you need to use the structure of a sub n equals a sub x times r to the n minus x. I'm going to use this one as a sub n and x, sorry, a sub n and n as a pair. And I'm going to use this one as a sub x and x for a pair. Go ahead and plug into this formula and see if we get the same r value. Pause your video now. Okay, so we get that r is equal to 1/2. Go ahead and check that. Follow through my work, see if everything makes sense. And then I'm going to have you pause again and see if you can go back and find a sub 9. So go ahead and pause. Okay, so after you find your common ratio, we need to go back and make a general formula. So you have two options. You can use this general formula that used the pair 12, 13, and 1/28, or you can use this general formula, which uses the pair of 5 and 13. It doesn't matter. You should end up with a sub 9 being equal to 13/16. Alright, given a sub 1 is 36, and a sub k plus 1 is equal to negative 2/3 a sub k, we should recognize this as being recursive because we've got this k plus 1 being dependent on the previous term. So thinking about our recursive definition, a sub n plus 1 equals r times a sub n, this right here is going to be our common ratio. So check that one off the list. If I want to find the first 5 terms, that means I'm looking for a sub 1. Well, I already know that, 36. A sub 2 is going to be equal to negative 2/3 times 36. A sub 3 will be equal to, this is going to be negative 24. This is going to be negative 2/3 times negative 24. A sub 4 will be based off of what you get for a sub 3. And a sub 5 will be what you based off of a sub 4. So a sub 3 comes out to be 16. And then negative 2/3 of that is going to be negative 32/3. And negative 2/3 of that is going to be 64/9. So we've got the first 5 terms. The nth term then, a sub n equals, you could pick any of these to be your a sub x. I'm going to choose negative 24. And that was when x was equal to 2. And I have my common ratio of negative 2/3. Okay, you could have picked any of these, put a 36 here and a 1 there, put a 16 here and a 3 there, doesn't matter. So now if I want to find a sub 12, I'm just going to use the formula. And you end up with approximately 0.416. Practice with your calculator. I know I don't have mine, but that doesn't mean that you shouldn't know how to use yours. Okay? A sub 12. Got all of them. Alright, so again, geometric sequence, common ratio. This one, but we used x's here. Okay, because you can have any a sub value. And then also we know that recursively, a n plus 1 is equal to r times a sub n, and you'd have to be given an initial condition. Those are geometrics.